Today I'm going to derive the equations for multiplying and dividing uncertainties to show why we need to use relative uncertainties in those calculations. So given two values, two uncertainties, we have these values here and we want to multiply them. So what I'm going to do is I'm going to start this derivation by pulling out an x and pulling out a y from each. So if we pull an x out, this will be plus or minus because they're uncertainties. X bracket 1, because we're pulling the x out, plus or minus delta x over x. And remember, delta x is separate from x, so you can't pull just the x out, right? And then same with y, we'll pull y out. We get 1 plus or minus delta y over y. So what can we do with this? Well, what I'm going to do first is I'll pull both the x and y out front just to make it easier to visualize. Now what I'll do is I'll distribute these into each other. So we got our x and the y. 1 times 1, we get 1. We get 1 times delta y over y, which is plus or minus delta y over y. And then delta x over x times 1 is plus or minus delta x over x. And then finally, we get delta x over x plus, or multiplied by delta y over y. So we get plus or minus delta x, delta y over xy. So now we have our formula in this form. And one thing I'm going to do is notice, I'm going to look at this term here, and due to the natures of uncertainties being small, we know that delta x is small, and we can say it's small by saying it's less than 1, say. Actually, that's not good. We'll just say delta x small, delta y small. So if you do x times y, delta x times delta y, it's very small. Because if you times a small number by a small number, you get an even smaller number. So what I'm going to do is, because this is very, very small, I'm going to assume this is 0. And we don't need it anymore. We can safely exclude it because it doesn't contribute as much to this equation. So that gives us x times y times 1 plus delta y over y plus or minus delta x over x. Okay, now what I'm going to do is I'm going to multiply this, distribute it back into this equation. So we got x plus y plus or minus. And what I'm going to do is I'm going to put the xy here and then combine these two equations, or these two terms of the equations in the brackets. Delta y over y plus, and so I also pulled out the plus minus, so the plus minus can just be out here, and that only leaves the plus. And we have something like this. So if you notice, this is our value, this is our value, but these are the relative uncertainties. So they pop up in here because you've got your actual uncertainty value divided by your the actual value corresponding with that uncertainty, and that gives you the relative uncertainty. So this is just in the form of, if we want the answer to be z, it's basically just z plus z and then it's the relative uncertainties, so delta z over z. So if you cancel out these two z's, it'd be z plus delta z, which is, the answer that we want. Now, so that's where the relative uncertainties come from. Now, sometimes we've written it in the form of z plus or minus, this should be plus or minus, just the z over z, which is fine too. But this term here, like this would be an example where we were like 10 plus or minus 10%. But then the value comes back in here if you want to convert it back into its actual form. So that would be saying like 10 plus or minus 10 times 10%, which would be 10 plus or minus 1, right? So that's what this is here. And so this is where the relative uncertainties pop up. Now we can do the same for division, and I'm actually not going to derive that because it's exactly the same derivation, except you take your x plus delta x divided by y plus delta y, and it gives you x over y plus x over y multiplied by delta x over x plus delta y over y. Okay, and if I bring back this, one thing I forgot to talk about is if you multiply this through, I'll write it up here, you get xy plus or minus x delta y plus y delta x. So that's maybe a nicer version of the formula, but it's easier, in my opinion, and the reason why we use relative uncertainties is it's easier to just divide the uncertainty by the actual value, then multiply the value of the other uncertainty by the uncertainty of the other value and whatnot. Even just saying it is confusing. So it's good to just write it in relative uncertainty form like this. I think it's more clear. So this is multiplication, and this one is for division, and they're in pretty much the same form. It's just what you do with the values that is different. So you divide the values. But these relative uncertainties, they appear in both. And so that is why you use relative uncertainties for multiplication and division of uncertainty values.